My dear friends, welcome to Rajashekhar classes on Applied Data Science with Python. This is lecture number 466. In this lecture, I will continue my discussion on A/B testing. Before understanding this particular lecture, I request you to go through my previous lecture, that is lecture number 465. In this particular lecture, we were discussing that what we were discussing, how do you compare CTRs? Just see, this is CTR of A, this is CTR of B, isn't it? Comparison of CTRs is not that straightforward. Why it is not that straightforward? Let me explain you why. Let's assume I have A here. This is, let me say, this is my A. Which one? Let me say this is A, isn't it? A here. I have my control here. This is control. And this is B. This is known as treatment, isn't it? Set A, I have set A and set B. So I got CA. What is this CA? CA means this is CA clicks, isn't it? What is NA? NA ads shown, isn't it? CB means what? CB is CB clicks and NB ads shown. Because we are not splitting the data, 50%, 50%. We are not splitting the data 50%, 50%. That's what we discussed in our previous lecture, isn't it? We could split this data 95%, 5%. Even you can split this data 90%, 10%, isn't it? It could so happen that, let's assume I have got 100 clicks here and I have shown 10,000 impressions. Let me assume I have 100 clicks and 10,000 impressions. What is my CTR? What is my CTR of A? CTR, number of clicks by number of ads shown, that is impressions. That what is this value? You are getting 1%. Let's assume, now let's look here. Let's assume here I have shown only 100 ads. Just see this one. What it say? 100 ads. Only I have shown only 100 ads. Only 2 clicks. How many clicks? 2 clicks. What is my CTR here? What is my CTR of B? 2 by 100. That is 2%. Now, if I compare CTR of A with CTR of A with CTR of B, I might conclude that my new model MNew, let me say my new model is MNew. My new model MNew, isn't it? My new model MNew better than old model. It is better than my old model. But that's incorrect conclusion, because I have only shown 100 ads. Just see here, I have only shown 100 ads. But in the case of MWorld, we have shown, in the case of MWorld, I have shown 10,000 ads. When we are computing CTR of A, we should compute confidence interval. We should compute what you have to compute. There is something like confidence interval. Confidence interval, isn't it? Confidence interval on what? Confidence interval on CTR of A. We learned how to compute confidence interval in our previous lectures. This is one of the best application. I can say it is one of the best application. It is one of the best application of confidence interval in the real world, as far as my professional experience. This is where I used a lot, super duper important. So given 100 clicks, given 100 clicks, 10,000 ads shown. How many ads shown? 10,000 ads shown. Instead of just saying 100 by 10k, what if I compute confidence interval 95% confidence interval. If you've forgotten what is confidence interval, I request you to go through what is confidence interval. If you have any difficulty, again I will record a lecture on confidence interval. Please go back to the probability and statistic chapter and refer it once and revisit whole section called confidence interval computation. If you compute confidence interval for CTR of A, we would get a value 95% of confidence interval will look like this. If I have 100 clicks and 10,000 ads, let me assume I have got this particular confidence interval 0.8%, 1.2%. CTR of A, let me assume this is my confidence interval. CTR of A will be between 0.8% and 1.2%. Just try to refer some literature how to calculate on confidence interval. In my previous lectures, I already discussed this one, isn't it? If you think about my CTR of B, because I have very few clicks, just see, I have only 2 clicks, isn't it? If you think about my CTR of B, because I had very few clicks and very fewer impressions, number of impressions are also less, fewer impressions are ads shown than the case of A. If I compare, this is true if you compare to case A, your number of clicks and number of impressions are very less in case of B. Confidence interval will look, let me say this is my confidence interval for CTR of B, 0.55% to 7%. Look at this is very wide confidence interval, is it not? 0.55% to 7% means this is very wide confidence interval. This is 95%, 95. This I can say, let me say this is wide confidence interval, 95% confidence interval on my CTR of B. Even though if you take the point estimation, what is point estimation? CTR of A 1%, and what is my point estimation? 2%. This is point estimate. This 1% is less than 2%. This confidence interval is so wide. This confidence interval of CTR of B is so wide, 0.55% to 7%. If I repeat this experiment, there is a 95% of times I will see CTR of B. What is my CTR of B? Lying between 0.55% and 7%, which is wider compared to CTR of A confidence interval. This interval which is much more tighter. This is tighter. This is tighter confidence interval. This is wider confidence interval. If I draw confidence intervals as boxes, let me draw this confidence interval as boxes. Let's take CTR of A. This is CTR of A. The center is 1%. Just see, this is center. Center is 1%. This is 95% confidence interval. This is 0.8%. Medium point estimate 1%. This is 1.2%. Isn't it? This is for CTR of A confidence interval, 95% confidence interval. CTR of B is 95% confidence interval. Your lower limit 0.55%, upper limit 7%, your point estimate 2%. Let's overlap both of them. How can I overlap both of them? Just let me draw it first. This is my CTR of B, isn't it? This is my CTR of B. What is CTR of B? This is 0.55%. This is 2%. This is 7%, isn't it? Yes. Now let's overlap both of them. Just I am overlapping both of them. What's happening here? Just see, this is What is this? This is 7%, 7%. This is 2%, 2%. This is what is this? 0.55%. This is what is, if I overlap, this 0.8 will come here. This this, what is this? 0. This one is what is this? This is 1.2%, isn't it? Yes, this is what is this? Is in between center you can have. What will you have? Just see this one. Yes, this is 1%. Just I am overlapping both of them, isn't it? How can I overlap? This is 1.2%. This is actually 1.2%. This is actually 1%. Just see, this is 1%. This is 0.8%. This is 0.8. This 1%. This is 1.2%. Isn't it? This one 0.8 to 0.8 to 1.2. This portion. Isn't it? What about this one? CTR of B 0.55 to 7%. Isn't it? So when you draw the confidence interval on one on top of the other, they are fully overlapping. So you can't actually by looking 2% and 1%, you can't conclude that CTR of B is greater than CTR of A. You should never do that. You should actually look at confidence interval and see if confidence intervals are overlapping. Then you can't be sure that there is certainly possibility that CTR of A should be better than CTR of B. So the best thing to do in such case is to compute confidence interval of CTR of A and compute confidence interval of CTR of B. If your data is looking like this, isn't it? These are not overlapping. Just see, this is my CTR of A. Let me assume this is my CTR of A. This is my CTR of B. They are not overlapping. Then you are sure that your B is certainly better than CTR of A. Look at the point estimate. If you look at the point estimate in both the cases, also width to be really sure that your model B is better than model A or better than model A or my old model. To be really sure that your confidence interval should not overlap. So what I touched upon very basics of A/B testing. A/B testing is full-fledged subject in itself. There is a whole one semester on A/B testing in some universities or in statistics departments. So what you are touched upon the core concept itself. So there is a concept called AA testing. AA testing is a very interesting concept. Suppose if you have your set of users, let me say you have set of users, you break them randomly into two groups, group A and group A, isn't it? Suppose you have old model, M-old. So what you typically do is break your users into two groups and run the old model in both cases. You run the same model in both cases. You will get the CTR of A here. In both cases, you will get CTR of A. In the case of A here, you will also get CTR of A in both the cases, isn't it? These two CTRs need not always be same because you randomized your data, isn't it? The data that you have seen here is slightly different. This data is slightly different from this particular data, isn't it? They are slightly different data, isn't it? The data seen here, and the data seen here, the difference, there is a small slightly they are differ, isn't it? That you get is slightly different from this particular data is slightly different from this particular data. AA testing is used as follows. Typically, Why it is different? You are randomly partitioning the data, isn't it? Typically what people do is, you have your whole universe of users. Let me say you have your whole universe of users. You break let me say like this. You have your whole universe of users. You break them into two groups. What are those two groups? One group is this A, B, isn't it? So you train your old model here. You train your old model here. Just see this. You train your old model here. You train your old model again here. You train your new model, MNew here. Now what you do is this. What you do? You get CTR of A. You get CTR of A here. You get CTR of A here, isn't it? Let's call this is CTR of A dash. Let's call this is CTR of B here. Now if CTR of B is greater than CTR of A, let me assume if CTR of B, let it be greater than CTR of A, and CTR of A also CTR of A dash. Let me assume your CTR of B is greater than CTR of A. Let me say like this. Yes. Let me say your CTR of B is greater than CTR of A, comma, CTR of A dash. See the difference between these two CTRs. Which CTRs? CTR of A and CTR of A dash. The difference between CTR of A and CTR of A dash will tell you how different with the same model, performs by just having slightly different data sets. So that the difference between CTR of A and CTR of A dash will tell you about what is the variance in estimation of CTR of A, because you are taking the same model, right? You are simply taking the same model. So when you want to compare, oftentimes what people do is they train two similar models. Let me say I got 5%. Let me say I got 5% CTR here. Let me assume this is 5% CTR here, and here 5.5% CTR. Here in this case I have got 5.4% CTR. If I compare just CTR of A with the CTR of B, we can conclude that CTR of B is better than CTR of A. But I could have gotten that 4% lift, isn't it? Just because of randomness of split. If we change this splitting slightly, model A itself, the old model MWOLD itself gives 5.5%. Itself give 5.5%. Even though 5.4% is greater than, even though your 5.4%, your 5.4% is greater than 5%. Just see, this one is greater than this, isn't it? We would not conclude that new model MNew is better, because by just changing the sample, remember it's same model, I am using MWOLD. Just see, just here I am using same model MWOLD, slightly different sample here, slightly, yes, you are slightly different sample, maybe 50% data, maybe 50% data. This is it may happen that here it may happen that here it may be 50% data, here it may be something like the 30% data here. This is maybe 20% data, isn't it? Different samples, maybe 50% went to A, and 30% went to second A, and 20% went to B. By just changing the sample of users slightly, I got different value, that is 5.5% here. This value 5.4% got here lies between 5.5% and 5.5%. Actually, my new model is not doing anything fun, just because of randomness in the split, that my model B is getting slightly advantage, but that's not actually significant, because running the same old model on the slightly different data is giving 5.5%. This happens few times. These are called AAB test. Split the data into 3 groups to see if really new model MNU is performing better, or it is just because of randomness in the splitting that one model is performing greater than others. Again, to be very frank with you, A/B testing is very large topic or very interesting topic, but in machine learning we mostly use it in this limited context. It is actually preferable to do AAB test. Just go through this lecture. If you have any difficulty, please keep a comment. Thank you very much.